All right, let's go through the last couple examples in this section. All right, so it says, given that sine of pi over 12 is root 6 minus root 2 over 4, determine the value of sine of 49 pi over 12. First of all, none of these numbers are on our unit circle, or at least they're not. We don't know these on our unit circle. They're not on our picture. All right, so how can we possibly figure out sine of 49 pi over 12? We don't know where to find it on the unit circle. It's hard, it's difficult. We can actually use properties of our trig functions, and we're going to use the periodic property of sine to do it. So I'm going to write a little note here. The period of sine is 2 pi, which means sine repeats after 2 pi units. Okay? So all we have to do is show that 49 pi over 12 is 2 pi, a multiple of 2 pi units away from pi over 12. So for example, here's what we're going to do. We're going to take 49 pi over 12 and subtract 2 pi. All right, and then I'll tell you why we're going to do this. All right, in order to do this, we need to get a common denominator of 12. And so we get 25 pi over 12. All right, the reason why we did this is because sine of 49 pi over 12 is going to be the same as sine of 25 pi over 12, which we don't care about this. Let's subtract 2 pi again. Common denominator. Pi over 12. This is what we do care about. We just found that 49 pi over 12 is a distance of 4 pi away from this one. All right, so 2 multiples of 2 pi. The point is, sine of 49 pi over 12 is the same as sine of pi over 2 because the period of sine is pi. So we can now say that sine of 49 pi over 12 is the square root of 6 minus the square root of 2 over 4. And we know this because of the periodic property of sine. Okay, so now what we're going to do is use properties of our trig function. So we're going to be using periodic properties. We're going to be using even and odd properties. So I'm actually going to write those at the top. All right, so the properties that we know right now is that tangent is an odd function. So we know that tangent of negative t equals negative tangent of t. And we also know that tangent is periodic pi. So that means tangent of t plus pi is the same thing as tangent of t. It repeats after pi units. So we're going to use that to simplify this problem that we're given. So I'll rewrite the problem. We're given that tangent of negative 3t minus tangent of negative 3t plus pi. And we want to figure out what this equals to. We want to simplify it. So we're going to use one rule at a time. All right, so the first thing I notice that inside of my tangent I have a negative number. Okay, we know that tangent is odd, so this is the same thing as taking the negative completely outside of our tangent. So now we have negative tangent of 3t. All right, let's look at the next piece. Tangent of negative 3t plus pi, this pi is important. Tangent is periodic pi, so that means this is going to be the same as if we didn't add pi at all. All right, right, so now we have negative tangent of 3t minus tangent of negative 3t. Well, what do we have here? Oh, we have a negative inside of our tangent. We already know we can take the negative out because tangent is an odd function. So let's do that. All right. Two negatives make a positive. Negative tangent of 3t, positive tangent of 3t, that should equal 0. So that statement actually just equaled 0, and we were able to simplify it using our two properties of tangent, that tangent is an odd function, and that tangent is periodic pi. It repeats after pi units. All right, so last thing, we want to make sure that we can use our calculator to approximate trig functions. So remember, when we use our calculator, it's an approximation. It's not exact, okay? So that's why this question says approximate it, and we're going to round to 4 decimal places. All right, so notice that it doesn't say anything here. All right, so if it doesn't say anything or have a degree symbol, that means our calculator needs to be in radians. So if there is no degree symbol, we are using radians. All right, so let's change our calculator mode to radians. Okay, first thing we're finding is cosine of 2 pi over 7, so we use cosine 2 pi divided by 7. Here's what I get, and I'm going to round it to 4 decimal places. All right, next we have cosecant. Is there a cosecant button on our calculator? No, there is not. So how do we figure out cosecant? Well, it is not the inverse of sine, it's the reciprocal of sine. So we have to rewrite it as its reciprocal identity. So we have to use 1 divided by sine of 0.92. And so let's see what we get here. 1 divided by sine of 0.92. All right, and then we just want to round this to 4 decimal places. All right, so I know the section was a lot. So the main things you really need to take away is, can you evaluate trig functions using the unit circle? Can you determine domains of our trig functions? And can you use our trig identities? So reciprocal identities, quotient identities like tangent and cotangent. Can you use the Pythagorean identities? Those are really important. I would say even, odd, and periodic are secondary, but you do need to be familiar with those. So if you have questions, make sure you ask me about them in class, and I will see you there.